The topic of this problem is nodal analysis, and in this problem we're going to solve a circuit with independent voltage sources. The problem itself is to find the current I sub 0, and I sub 0 is defined as the current flowing down through the 2 kilo ohm resistor in the center of the circuit. So when we're doing nodal analysis, the first thing we do is we identify the nodes in the circuit. So let's do that. The top node is at the circuit. The top node we're going to call node 1. We also have a node on the left-hand side of the circuit, and we're going to call that node 2. We have a node in the center of the circuit. We're going to call that node 3. We have a node at the right-hand side of the circuit, node 4. And we have the reference node or ground node at the bottom of the circuit, which is at 0 volts. So we're going to write the nodal equations about each of those nodes. And to do that, we use Kirchhoff's current law, and in this case, we're going to sum the current into the nodes. With Kirchhoff's current law, we know that we can either sum the currents into or out of the nodes, and either one will work. We just need to be consistent throughout the problem when we're solving it. So the first thing we're going to do is we're going to look at node 1. And we look at node 1 and we see that the top node has 3 currents flowing into it. We have current flowing through the 2 kilo ohm resistor on the left-hand side. We have current flowing through the 2 kilo ohm on the right-hand side. And we have current flowing up through the 12-volt source. So if we were to write an equation about that node, then we'd have to introduce an additional unknown current. Let's call it I 12 volt, because we don't know the current that's flowing up through the 12 volt, and we cannot identify it without introducing an additional variable. Since we have 4 nodes, we expect to have 4 equations using our conventional Kirchhoff's current law solution process. But because we have this additional unknown for the I 12 volt, the current through the 12 volt source, we would end up having 4 equations and 5 unknowns and would not be able to solve the problem using that approach. So what we do in problems where we have independent voltage sources which aren't tied to ground, so that we know that the reference voltage on at least one side of that voltage source, we use the concept of a supernode analysis to solve the problems. So in this case, we're going to identify a supernode which encompasses node 1 and node 3 and the 12 volt source. So it will travel and connect and encompass node 1, node 3, and the 12 volt source. That is our supernode. Once we've identified that we need a supernode in the problem, we can then go about summing the currents about the different nodes. So for the supernode, we see that we have a current on the left-hand side coming in through the 2 kilo ohm resistor on the left-hand side. We have a current flowing into the supernode through the 2 kilo ohm resistor on the right-hand side. Similarly, we have currents flowing in through the 1 kilo ohm on the left-hand side and the 1 kilo ohm on the right-hand side. And we have the current flowing up through the 2 kilo ohm resistor at the bottom of the circuit. So let's add those currents up, starting with the 2 kilo ohm resistor on the left-hand side and the current through it upwards into the supernode. That current, and this is the supernode equation, is V2 minus V1 divided by 2 kilo ohms for the current through the 2 kilo ohm resistor flowing into the supernode on the left-hand side of the circuit. Similarly, for the 2 kilo ohm on the right-hand side, we have the current V4 minus V1 divided by 2 kilo ohms for the current flowing upward through the 2 kilo ohm resistor into the supernode. We also have the current flowing left to right through the 1 kilo ohm resistor in the center of the circuit. That's V2 minus V3 divided by 1 kilo ohm. The current through the other 1 kilo ohm resistor from right to left, from the node 4 to node 3, is V4 minus V3 divided by 1 kilo ohm. And then we have the current which is flowing upward through the 2 kilo ohm resistor in the bottom of the circuit. And that's going to be the reference voltage, which is 0 for the ground node, minus V sub 3 divided by 2 kilo ohm. And that's equal to 0. So we have our 5 currents flowing into the supernode that constitute our supernode equation. Now we're going to go to node 2, and we're going to sum the currents into node 2. We notice that in node 2 that we have a voltage source tied to it, which is the 6-volt source. We know that also with nodal analysis, what we're ultimately looking for are the nodal voltages. So in this problem, since we have a voltage source between node 2 and the ground node, which is at 0 volts, we can determine the nodal voltage for node 2 very easily. And we can do that simply by writing the equation relating the nodal voltages with that source. The bottom node is at 0 volts. It's tied to the positive polarity of the 6-volt source. So we have 0. And we notice that node 2 is tied to the negative polarity of the 6-volt source. So it's minus V2 is equal to 6 volts. We have an equation for node 4. I'm going to go ahead and call that the node 4 equation. And in a similar fashion, we can find nodal voltage for node 4 directly from our circuit. And in this case, it's V4, which is tied to the positive polarity of the 12-volt source, minus the ground. So it's V4 minus the reference voltage, which is at ground, 0 volts, is equal to 12 volts. So we know V2 and V4 from these two equations. If we look at our supernode equation, we have 4 unknowns. So right now we have 3 equations and we have 4 unknowns, 2 of which we've found very easily. The last equation that we need is the equation which relates the node voltages to our supernode. And so if we look at the supernode, we can easily see that for the supernode, our constraining equation for our supernode is going to be V1 minus V3 is equal to 12 volts. So now we have 4 equations and we have 4 unknowns, V1, V2, V3, and V4. Ultimately, what we're looking for in this problem is we're looking for I sub 0. I sub 0 is related to V sub 3. If we were to write the equation for I sub 0, we see that I sub 0 is equal to V3 minus the ground voltage, so it's coming down through from V3 down to ground through the 2 kilo ohm resistor. That's our I sub 0. So if we're looking for I sub 0, really what we're after is V sub 3, because once we find V sub 3, we can solve for I sub 0. Right now we know what V2 is, it's minus 6 volts, and we know what V4 is, it's 12 volts, but we don't know what V1 is, and we don't know what V3 is. So we're going to solve our set of equations for V3. And if we do that, we end up with a V3 which is equal to minus 6/7 of a volt. Once we have that, we can then solve for I0. And I0 is going to be, using our equation that we have on the left-hand side of our board, we have an I0 which is equal to minus 6/7 of a volt divided by 2 kilo ohms, and that comes out to be minus 3/7 milliamps.